Does the brand of chalk really make that much difference? To answer this question, I've done a careful set of experiments to find objective and fact-based answers. I tested 5 of the most commonly used and/or most often discussed chalks: Pre-Flag Master, Master, Lava, Blue Diamond, and Kamui, 0.98. 4 different tests were performed to determine the amount of cling, skid, or kick caused by a chalk mark on the cue ball, the number of sidespin shots possible with a single application of chalk before miscuing, the miscue limit for maximum sidespin, and how long chalk marks persist on the cue ball after multiple shots. All balls used were cleaned before each test with Aramith ball cleaner. An elephant practice ball was used as the cue ball to give a clear aim point for applying a constant amount of sidespin and for checking chalk mark locations relative to the expected miscue limit. If you are not interested in seeing the shots from all of the tests, you can fast forward to the conclusion section at the end of the video for a summary of all of the results. The purpose for the first test was to determine the amount of cling, skid, or kick caused by chalk marks. Remember, cling is an excess amount of throw caused by extra friction at the ball contact point. To measure cut-induced throw, a ruler template was taped to the rail. A square hit results in no throw, sending the object ball very close to the 0 point on the scale. To check for throw and chalk-induced cling, I used a 45-degree angle frozen combo shot shown here. The balls were tapped into place and marked with self-adhesive hole reinforcement donuts to ensure consistent ball placements. As a baseline, the clean balls with no chalk marks were tested for the expected amount of throw. The amount of throw varies some with speed, but the shots with the most consistent speed were selected for the video to provide meaningful averages. Before each experiment involving chalk, the tip was carefully cleaned and scuffed before applying the test chalk. The first cling test was done with master chalk. First, the cue ball was struck with the chalked tip to create a natural mark on the ball. Then the chalk mark was placed at the contact point of the frozen combination shot. This was done many times with the 3 most consistent speed shots shown here. Then a spare piece of tablecloth was used to lightly wipe off the chalk mark, and the test was repeated with the wiped off mark at the contact point. Again, this was done several times, and only the average shot is shown in each case. The same set of tests was done for each of the 5 chalks, and the results are summarized later. Here's a summary of all of the results. They will be discussed at the end of the video. The purpose for the next set of tests was to determine how many shots could be hit before miscuing after a single application of chalk. For every shot, the center of the cue was aimed at the center of the red circle edge. The cue was also held in the same orientation for each shot, with a small marker at the joint pointing straight up. This caused the same part of the tip to hit the cue ball on each shot. The chalk mark on the cue ball was completely wiped and rubbed off with a cloth after each shot. 2 sets of shots were done on each side of the cue ball, and only the set resulting in the largest number of shots on each side is shown in the video. After each miscue, the tip was scuffed and fresh chalk was reapplied. Here are the selected sets of shots for each of the 5 chalks. Here's a summary of all of the results. They will be discussed at the end of the video. The purpose for the next experiment was to determine if the maximum amount of sidespin, or miscue limit, varied with the type of chalk. The expected miscue limit is about here, where the tip contact point is at the edge of the red circle. For each chalk, a large number of shots was attempted at increasing tip offsets from center. Only the 3 largest tip offsets for each chalk, along with the miscue, are shown. As you'll see, all of the results were very similar. With no chalk on the tip, not very much sidespin can be applied. The purpose for the final test was to determine how long chalk marks stay on the cue ball after multiple shots. The longer chalk marks persist, the greater the chance that cling will occur. The same 3-rail kick shot with top right English was repeated 6 times with each chalk. The cue ball was positioned each time, so if the chalk marks persisted, they would all be in the same general area on the ball. Here are all of the shots. With the master chalk, only 2 of the retained chalk marks were clear. 1 was faint, and 2 others were very faint. With the master pre-flag chalk, only 2 of the retained chalk marks were clear, 2 were faint, and 1 was very faint. With the lava chalk, only 2 of the retained chalk marks were clear, 1 was faint, and 1 was very faint. With the blue diamond chalk, 5 of the retained chalk marks were clear, and 1 was faint. With the Kamui chalk, 5 of the retained chalk marks were clear and 1 was very faint. Here's a summary of all of the results. They will be discussed with the other results next. Here's a summary of the results from the cling experiment. All of the chalk marks resulted in significant cling. The amount of throw in each case was much greater than with the clean set of balls with no chalk mark. The Kamui chalk resulted in the largest cling. Even after the Kamui chalk mark was wiped off, the residue still created more throw than with the others. Here's a summary of the results from the number of hits before miscue experiment. The Blue Diamond and Kamui chalks took much longer to lose effectiveness. The single application of Kamui chalk lasted for almost twice as many shots as the others for the amount of sidespin tested. Here's a summary of the results from the chalk mark persistence test. Both the Blue Diamond and Kamui chalks seemed to stick to the cue ball more and be retained longer. After 6 shots, the chalk marks from the last 5 shots were still clearly evident and at risk for cling. Therefore, one would expect cling to be more likely with the Blue Diamond and Kamui chalks. Here's a summary of all important conclusions from the tests. All brands of chalk result in cling when a chalk mark appears at the cue ball object ball contact point. Kamui chalk seemed to result in slightly more cling than the others. All of the chalks seem to perform equally concerning maximum sidespin and miscue limit. With no chalk, very little sidespin can be applied, so chalk is important. It just doesn't seem to matter which brand you use when it comes to getting maximum sidespin, assuming the tip is chalked before each shot. With a single application of chalk, the Blue Diamond and Kamui brands lasted many more shots before losing effectiveness. So if you don't chalk before each shot, or if you don't chalk properly, these brands might result in fewer miscues. Both the Blue Diamond and Kamui chalk marks stuck to the cue ball more and were retained longer between shots. This could result in more frequent cling. As always, you should wipe chalk marks off the cue ball every chance you get. Definitely wipe the cue ball off anytime you get ball in hand, and before every game before breaking. One more observation concerning Kamui chalk was that it goes on the tip very smoothly with no abrasive sound or feel at all, almost like lipstick. One possible advantage of this is that it might not wear down the tip as fast. A possible advantage of the other chalks is that they might help keep the surface of the tip slightly scuffed, helping the tip hold chalk better. Finally, I didn't show numbers during the test, but I did check the squirt or cue ball deflection values for many of the shots, and the numbers clearly showed that the amount of squirt does not vary with the type of chalk. Here's the bottom line. The type of chalk doesn't really matter much, unless you don't chalk often or well enough, in which case the Blue Diamond and Kamui might help, although they can result in more frequent cling. Remember, chalk before each shot and keep the cue ball as clean as possible.